we were informed that Quantinuum's recent result with 56 qubits, which was shocking to us, and also Q-era computing from Harvard and MIT spin-off recently selling its quantum computer to Japan, which the amount was around $41 million. So what do you think about those results and how IonQ will, compete with those kind of results?
So the two are different. And on the one hand, you have a technological achievement from Quantinuum, which we see as a stepwise change in their performance and is below what we have said our target is. And so we welcome the fact that Quantinuum continues to develop. However, we don't think that this is anything out of the ordinary. And the important thing about qubits is that you need to be able to use them. So we have long been talking about our arithmetic qubits, or AQ, and that is a very important concept because it's about time to solution. It's not just about how many qubits do you have, because that's not meaningful if it's physical qubits. And when it comes to the architecture that Quantinuum is utilizing, it is a racetrack where in order to compute on qubits, they need to move them together and then move them back to the racetrack. So you move them together to do the entanglement and compute, and then you move them back. And ions or qubits are very sensitive to the environment, so you need to cool it down so it doesn't get overexcited. This act of shuttling and cooling takes up most of the time that Quantinuum's H2 computer spends. So if you look at the tables that they have laid out in their white paper, you can see that roughly 98% of their computer time is not spent computing, it's spent moving and cooling down the qubits. We think that the time to solution is much longer than it needs to be, and as a result, you dramatically reduce the capacity of that computer.
And so in summary, like Thomas said, we congratulate Honeywell or Quantinuum we should say, on their choice of qubit, because we believe this is just edifying evidence that trapped ions are the best approach. But we also think that the IonQ architecture is superior and will continue to scale better in the long term.
So we should look for other perspectives, not just focusing on qubit counts.
That's right.
What are the things and efforts that IonQ is doing that the competitors, IBM, Quantinuum, Q-era computing, etc., are not doing?
That is a long list. But if we take a step back to Q-era's $40 million sale to Japan, very little is known about that sale. And we don't believe that it does anything to what we're doing. Very little is known of the actual performance of Q-era's computer.
We don't know exactly what has been sold to AST because it's not our company, so we don't know what's in the contracts. But what is one thing that we're doing that's different than other quantum companies? We are starting production, for example, because we have confidence in selling our systems. We just announced on the last earnings call that we're developing 5 Fortin enterprise systems and are in various stages of discussions on selling those systems as well. And we think that not just having more systems, but the process of moving towards production and manufacturing will make us a better company, will make our product offering more serviceable, will make it more manageable. And so that entire process takes a lot of time and effort and thinking, and we're very glad that our team has started working on it.
I figured out that IonQ is the only company focusing on making the hardware smaller. I asked the person on Q-era computing that they are not focusing on that yet. They want to achieve the quantum supremacy first.
Right, and form factor matters. The first thing that we're focused on with our Forte enterprise systems is making sure that our systems can go into a customer's data center, so they don't need to make radical adjustments to be able to host IonQ systems. And so we're going to increasingly get towards a plug-and-play approach for providing products to customers.
That's right. That's why we refer to rack-mountable
Right.
computers, because that's how, if you operate a data center, that's how you're used to thinking about it. And what we've always said is that we want quantum computers to be both cheaper and smaller, because we don't believe that this is a certain type of development where you have one computer per country or per region. We want there to be quantum computers everywhere. And to do that, you need to make something that is useful to the customer.
Right.
It's not just a scientific proof point. It needs to be something that goes into your fleet of compute that you use for your organization.
So the main location where QPUs will be located might be the data centers.
So most organizations today of size, who are the first one that will adopt the use of quantum computers, have data centers. That's where they put all their servers. Now these are designed in certain ways, and one of the main consideration is that all the computers have the same dimensions, so they can fit into a rack.
Right.
And therefore we think that it should be a goal for anybody that delivers compute, that you can fit into that form factor, because otherwise your customer won't just have to buy a computer, they have to build a data center. And for most players out there, that is the case.
Why do you guys think IonQ is able to gather top talents in the quantum and engineering fields? Why are they joining IonQ even though they have to reduce their pay? Because they're joining basically a smaller company.
It's a great question, Sean. I would say that people who are working on quantum computing recognize the potential that IonQ has and the momentum that we have, and that we're a great place to work and to do their best work. And that brings them to IonQ. They know they're going to be working with colleagues who are top of the industry. They know they're going to be working on real cutting-edge systems. And that is a very exciting prospect for people who believe in the vision of quantum computing. And so we're very lucky to call these people colleagues, and people are willing to roll up their sleeves and work hard hours and maybe sacrifice an opportunity elsewhere to come to IonQ.
Right.
And that's a great sign. We're lucky to all be united by that mission here at the company.
What do you guys think is the IonQ's biggest risk and weakness?
That's a tough one. For any company, there is the risk that you can't get talent. And that is the one that when I joined, when Jordan joined, we weren't clear. Because when you look at our management team, there was only Peter there before us.
Right.
And we were going public and we're building a company with very diverse needs. So how can we get past that? Well, the answer is very solid and steady recruiting. And today we have an all-star team of management who come from other companies with deep experience and background. It's not a startup that you're just there because you're there at the beginning. We have people who've done it before. And so that is a challenge that we feel that we've mitigated, but it's always a challenge. You can't ever just say back and, okay, I'm done recruiting now. But attracting and retaining the best talent is always your highest challenge in any company. And when it comes to that, I think other challenges are always like, well, is the market developing fast enough? Can we meet our technological milestones? And I think we have a team that's driven, and that enables us to do it. But if, when I joined, I would predict that we would deliver 35 AQ 1 year early, I wouldn't believe it. Like, even when we did it, I wasn't sure if I could believe it. And then we ran many tests and said, yeah, we actually did it. And then A month later, we did an additional qubit. When it comes to sales, it's like, sales are hard. As I said earlier, it's the hardest thing in most companies because there are outside factors. However, when there is no clear map, you have to trust your analysis. And the analysis says that quantum computing is the next step in computing writ large. Now, if you believe that, then you need to bring forward quantum computing. If you bring forward quantum computing, here are the steps you need to do. You need to make a computer of this size, and then you make it this much larger. You need to go to market. You need to build out a go-to-market function with sales and with marketing. You need to file things with the SEC. There are all these things which, if you sit down and write a list and just think about it, you can be so afraid that you can't do anything. And one person can't do it. I can't do it, Jordan can't do it, Peter can't do it, which is why you hire a team and you delegate responsibilities. And you know what? Once you build up a professional department, the head of that department can't do it either. And so they hire their team, and so on and so forth. And that's how you build great organizations. There's a lot of hard work, there's a lot of fun, and there's a lot of trust. And that's how I think that, yeah, we have massive challenges everywhere. But we also have great colleagues, and that's what allows me to sleep at night.
There's a lot of unknown in building a company in a nascent industry. That's the nature of it. Some people could choose to view that as a risk. We view it as a challenge and an opportunity. And that's why we have this incredible team around us working on that challenge and motivated by it and excited to push the boundaries together.
So the biggest risk might be not getting talented people anymore, in summary.
I think it would be, the biggest risk is always in attracting and retaining talent,
Okay.
but also becoming complacent. If you ever think that you've won and now you can coast, it's done for. Only the paranoid survive. And I should also say that one of the things that is great is to have such a vibrant field of people who follow the company. There's way more I have seen who interact with us on a daily basis that are following us than we were aware of. Like, we've worked for other companies, and those companies done great things, but it hasn't always been as much of almost an integration with the community. And that is great to see. That's actually why we're here in Korea today.
Yeah, we're very grateful for that engagement and for the great questions that you've compiled as well, Sean.
Alright, so this concludes our interview. Thank you for your time, Thomas and Jordan. Please have a safe trip back to America.
Our pleasure.
Thank you, Sean. And
Thank
thank you
you.
to you.
Thank you.
Thanks for joining.